So let's recall that in a previous section, we defined the average value of a function using finite sums and the midpoint rule. So we can recall that the average value of a function, which actually we shorthand denoted as f with a bar on the top, and we defined this as the area using the midpoint rule. So that midpoint rule with finite sums. And this was all divided by the length of the interval. So what's nice is that now that we have the definite integral, we can extend this formula into integration. So here we go. This is the new definition that we'll use from this point forward. So if f is integrable on a closed interval from a to b, then the average value, or the mean, is defined as f bar, and this is equal to that definite integral, the area under the curve, from a to b of f of x dx. So there's the area. And then we need to divide this by the length of the interval. So that's the difference of the endpoints, b minus a. And so oftentimes we'll simply rewrite this as 1 divided by b minus a multiplied by the definite integral from a to b of f of x dx. So this is the same formula as above, but the exact average value because we're using the definite integral. So let's look at an example. So here we go. Compute the average value of the function f of t is equal to 1 minus t squared on the closed interval from 0 to t. And so again, we're looking for the average value. So we're going to use the definite integral form, which is 1 over the length of the interval, b minus a, multiplied by the definite integral from a to b of f of x dx. Or f of t dt in this case. So let's start by first just finding the area under the curve, or the evaluating our definite integral from a to b of f of t dt. So we have the closed interval from 0 to 3 of 1 minus t squared dt. So in order to integrate here, we want to expand that binomial. So we can think about this as 1 minus t times 1 minus t. And if we apply our FOIL method here, we're going to end up with a beautiful polynomial. So I leave that algebraic work to you. And this will give you 0 to 3 multiplied by 1 minus 2t plus t squared dt. And now we're ready to evaluate or integrate. So we have t minus 2t squared divided by 2 plus t cubed over 3, which we can now evaluate from 0 to 3. And we see these 2's will cancel each other out to 1. So plugging in the bounds, we're evaluating at 3 first. So I have 3 minus 3 squared plus 3 cubed. I did a step in my head. This should be 3 cubed divided by 3, which will simplify. And then when we plug 0 in, everything cancels. So that's just minus 0. So we know that the 3 in the denominator here will cancel with one of those 3's. So we're left with 3 minus 9 plus 9, which simplifies to 3. So just be careful here. We're not just looking for the area. We want to find the average value. So here is the average value of our function f. So that's f bar, and we know that this is 1 over the length of the interval, so b minus a. So it's going to be 3 minus 0 multiplied by the definite integral, which we just found in the step above. So we're multiplying that by 3. So this is 1/3 multiplied by 3, and those 3's cancel each other out to 1, leaving us with a beautiful final answer for the average value of our function as 1.